Worked example 13, inductance AC circuit. A 100 millihenry inductor is connected to a single phase 100 volt 50 Hz AC supply. Calculate the supply current magnitude only. Okay, so in this case, again, if we're looking at magnitude only current, our I is going to be V over Z. But in this case, again, just like previously, because there's only an inductor here, our Z is basically just going to become XL. So effectively V over XL when we have an inductive only circuit. I don't really like teaching this formula because it's such a very specific application. It's only when you have an inductance only circuit. Effectively, you're just trying to teach people to rote learn how to answer this particular type of question without really thinking about it. I always think this is the formula you need to know, and you need to remember that when you've got an inductance only, your Z simplifies down to XL, not just that V is equal to V over XL, because this just creates more confusion in the long run. XL is equal to 2 times pi times the frequency times the inductance of the circuit, 2 pi FL. And so for that we can substitute in our 50 Hz times our inductance of 100 times 10 to the minus 3, and that gives us our inductance of 31.42 ohms. I'm not too worried about the J notation at this point, it is just magnitude only we're dealing with. So 31.42, and in this case that's going to give us our IS Vs over XL, which equals 100 divided by 31.42, 3.18 amps.